Hello, Mr. Price here, and this is the first video on the Jan 2006 M2 paper. We'll go straight into the first question. We have a beam in equilibrium. It's a uniform rod, and we know its weight is 20 newtons, and it has a 3 metre length, as depicted in our diagram. And we're told it's being held horizontally in equilibrium, and we want to find the tension in this string here. Okay. Now, what we could do, because we know in equilibrium the sum of forces in any direction are going to be equal, but unfortunately we're going to have two unknowns. We're going to have the tension in the string and then also the contact force here, which will be pushing this end up a little bit as well. So we can't do that, but we also know in equilibrium that the sum of moments in any direction will also have to be equal. And this will be quite handy because that way we can ignore the contact force A by taking moments about A. So this is what we'll do. So we're going to first do a very quick sketch of our diagram. So here's our wall, and then here is our contact point A, and then it goes across and then connects to C like so. And we know this is 3 meters. And we'll need this angle here as well because tension's obviously going to be at an angle and we're going to want to resolve perpendicularly to our lever here. Okay, and we know that this is 1 meter. Okay, so our first step we're going to do is we're going to want to find out what this angle is. So we can say that tan theta is equal to 1 over 3. So using inverse tan, we should get the angle as 18.435. Okay, now we know this angle. This is quite critical. We can now do just a simplified force diagram here with our lever. So here's our lever at A. We're going to take forces around here, and then I should say pivot here, and then we've got a force here from the string at an angle of theta. So if we take moments about A, and we'll go clockwise, we can say that we've also got a weight here, don't forget the weight, so it's a uniform rod, so it's perfectly in the middle, that's 20 newtons, and it's a 3 metre length, so that's 1.5 metres, and that's 1.5 metres. So we can say that from this pivot point here, if it goes down, it's going to cause a clockwise moment. So 20, and it's 1.5 metres from the pivot, so 20 lots of 1.5. Subtract, and then this tension going up is going to cause an anti-clockwise moment. So that's going to be negative, and that's going to be tension, and then it's perpendicular, so we're going to want the force in the vertical position. So T sine theta, and that's going to be 3 metres away from the pivot point, lots of 3, will equal 0. So we have one unknown here, so after some rearrangement you should find the tension in the string is 31.6 newtons to 3 significant figures.